In the previous modules of this course, we started the conversation about continuous integration and the AWS services you can use to leverage a way to develop something in a collaborative manner, from the source code to build and test. We also talked about Code Pipeline, the AWS service that can be used to orchestrate your continuous integration workflow, stitching together code commit and code build to automatically have the build done and tested according to the pushes in a Git repository. In this module, we are going to start talking about the next steps that you can leverage to continue evolving your pipeline until you have an effective way that can safely and quickly deploy source code into production environments. Commonly, the first stage of a continuous delivery process is provisioning. Provision means that you should be able to create and change environments according to the needs of the application artifacts, generated as the last step of your continuous integration phase. In other words, if your application now needs a dependency or you need to increase the auto-scaling configuration, provisioning is the stage in your pipeline where you can make these changes. Also, as we now may have multiple developers working together in parallel in the same project, we would like to automate the environment provisioning steps. This automation could be useful if developers checking different versions of the same code in a way that you want to make parallel tests on them to be able to choose which one is a release candidate that should be moved to the production in the future. Manually keeping track of every single environment configuration is hard because systems evolve over time, and keeping tests, staging, and production environments in sync is not an easy task. Automation is a key subject when we talk about this, and when we talk about having machines provisioning the environment for us, we have to find a way to communicate what we want to do to these machines. That's where infrastructure as code comes in place. Infrastructure as code is the process of managing and provisioning environments through code that you create. And since you can interact with the AWS infrastructure doing API calls, you can make a script that creates your entire environment. So whenever you want to change that environment, you just change the script and run it. Although the theory looks good, in practice, the approach of creating your environments with your own scripts has some disadvantages, mostly because you are being programmatic and not declarative. Let me explain the difference. When writing a script, you are giving exact instructions on how the infrastructure should be created. And because of that, you actually have to write not one, but two scripts. One to create the environment, and another one to terminate it. You also need to update these two scripts if you need to change something. And last but not least, you should implement the logic for infrastructure dependency between the components. Rolling back in case of failures is another concern, because if your script eventually fails, you need to remove what has been created so far to keep your infrastructure in a consistent state. All of these will add complexity to your infrastructure as code scenario. And one of the value propositions of CI/CD is bringing simplicity to the pipeline. Doing that with your own script is similar to going to a coffee shop and describing what should be done to get your drink ready. We just don't do that because coffee shops have qualified employees that can prepare what you want based on your request. We naturally use a declarative communication for that. You just order an espresso or a latte, and the barista knows what needs to be done to get your drink. AWS offers a service called CloudFormation that can build infrastructure based on a declarative file specified by you. The service can receive a file containing the infrastructure definition and create infrastructure components based on whatever is described. In CloudFormation, we call that file a template and the infrastructure components a stack. Everything starts with the template creation. You can use JSON or YAML for the syntax. When you have the template ready to become an environment, you input it to CloudFormation by executing an API call called createStack. CloudFormation will check what is in the template and will provision the resources accordingly. In this case, we have a very simple template that creates an EC2 instance and an S3 bucket, but CloudFormation integrates with almost every AWS service, allowing you to automate the entire infrastructure required by your needs. For environments that need to be run in long term, like production, CloudFormation also supports changes to running stacks. If you don't want to use that EC2 instance anymore, you can just edit the template and remove it. After that, ask CloudFormation to update stack, inputting the updated template. CloudFormation will make a diff between the two versions and will realize that the EC2 instance is not there anymore. So the instance will be removed from your environment when the update stack process finishes. Update stack not only works with adding or removing components, but also changing them. It's possible to transform a small instance into a large one, for example. Just change that in the template, update the stack, and CloudFormation will handle that for you. This create stack, update stack, and calls like describe stacks, delete stack, or others are AWS API calls, and these are authenticated by IAM, which means you can have fine-grained access control with IAM policies, groups, and roles. So as you saw, you can use CloudFormation to orchestrate your entire infrastructure set. The service also has a feature called CFN init, allowing you to configure the operating system of EC2 instances that are created by the stack. That is ideal because, for example, we can create and configure web servers and their dependencies and tools that are useful for monitoring and log shipping. That being said, CloudFormation is a very useful service and we can't imagine infrastructure automation without it. Having the ability to write a template and have the infrastructure created is a very good thing. But since we are talking about having a continuous integration and continuous delivery pipeline, it would be even better to have templates in the code commit repository, and whenever a change happens in one of them, code pipeline orchestrates the environment change. When we start doing this practice, we may end up having developers operating the infrastructure. And this is actually where the word DevOps comes from. Developers who also operate. DevOps. And because developers are good with code, when we talk about infrastructure as code, you are the expert. When we do this, we don't need to touch the AWS console to change infrastructure. We just change the template, push it to the repository, and code pipeline takes care of updating the environment. This is good because you can have some sort of infrastructure versioning over time, and we are now one step further on treating our infrastructure as code. The AWS documentation has many examples about how you can build up your stack set. You don't need to put your entire environment in the same template. You can have one for VPCs, another for databases, others for application environments, etc. CloudFormation allows you to create multiple stacks from the same template. So if you have a template that creates an environment, you can use the same templates to replicate multiple environments that look the same. Ideal for dev and staging environments.